Welcome back to watching our interactive stargazing live stream. My name's Jose with the Lowell Observatory, and what you see here is an image that is being taken with our Malincam camera over at our Giovale Open Deck Observatory. So I'm going to go ahead and just be taking lots of requests for cool space objects that you guys might want to look at tonight. I will be here until about 8:30, just looking at really cool space stuff and talking about space. So this object right here that you're looking at, this is called NGC 1893, and this is an open star cluster. And you can sort of see in the background a little hint of a nebula, sort of a little bit of purple and a little bit of red. And you can see there's some of these stars are a little cloudy. You can also see there's a little bit of a dark nebula in front of that. There's some darkness down in the lower left-hand side. And I think this cluster is really pretty. This is sort of what happens after stars have newly formed. And in fact, some of these stars look like they might still be in the process of forming and new planets are forming. We'll have gas clouds like this. They'll start to collapse just from their own weight, and they'll break off into these little segments of dense gas where we're going to have new stars, and eventually solar systems will start to be forming as well. So you can see a little bit of that, a hint of the pink cloud. And when something's pink like this, that tells us that it's probably going to be made out of, excuse me, I'm going to drink some water real quick. That pink gas is going to be made out of mostly hydrogen gas. And the stars that are forming inside it, they're emitting a lot of energy. And as that energy passes through the gas, it's going to get excited. The little electrons are going to start to jump around, and they're going to give off a lot of this light. And this pink light will be associated with hydrogen. Now, down in the lower left, you can see there's a little bit of a dark nebula. There's some, it's not quite pink, it's just really dark with fewer stars. And that's going to be a lot of dust. And that dust, that's blocking out starlight. My guess is there's probably quite a few stars that is behind that dust that we just can't see because it's blocking out that starlight. The starlight's going to get scattered. You might, if you had a really good infrared camera in space, you might get a really good image of the stars behind it because that dust will probably be glowing in an infrared color, infrared as well. So interestingly enough, this nebula that's behind it, it does have its own name. It's called IC 410. And this whole cluster is about 12,000 light years away from us. And the stars are there's about 4,600 of them in here. I'll give you guys time to count all of them if you'd like. But until then, I think we'll just move on a little bit and we'll start to, I see some requests are starting to come in. So we'll go ahead and start taking those. Now, we did have someone request Enceladus. Enceladus is one of Saturn's moons. And as we know, it's going to appear very close to Saturn in the sky. And Saturn is just really close to the sun now, so we can't actually view Saturn anymore. However, we do have a request for IC 418. So we'll go ahead, and what you can see here is my telescope operator, John Ford, on the other side of the camera. He is using our technology, our plane wave technology, to operate the telescope, which is a plane wave CDK 14-inch reflecting telescope. He's using that program that operates it in order to search for the object. And now we can see we have some star trails here as the camera is still taking a picture, but the telescope is moving to the new object. So I don't know what IC 418 is. Well, in about 15 seconds, we'll see what that is. We might want to start dropping down some of our exposure times for later objects because 25 seconds is a long time to wait for some things. And I do see a star. It is a small planetary nebula. in the constellation Lepus. And so that's what that single star in the middle is. It looks like one star, but it's actually a planetary nebula. Now, of course, we have a bunch of these planetary nebulae all scattered out through the sky. The winter sky has an abundance of them, although the summer sky has some of the brighter ones that are more visually appealing. Now, a planetary nebula is the result of a star that was very small, like our sun. It's gases that have been thrown off of it as it started to die. It lost all of its energy, and it started to push out layers and layers of gas. And you'll see these sort of spherical looking things with multiple layers of different gases of different materials. Generally, lighter gases like hydrogen will be on the outside, and then heavier gases like oxygen, those will be towards the center. So you generally tend to see it's kind of like an onion. And then at the center, you're going to see a white dwarf. Although here, the planetary nebula is small and faint enough that we can't actually pick out the white dwarf, which is the core of the star that had died. We have another request from JH, who wants to look at the star Capella. I absolutely love this star. It's one of the brightest stars in the night sky, and it's part of the constellation Auriga. And you guys can correct me if I'm wrong. I'm pretty sure it's part of the famous asterism, the winter hexagon, which is a really big formation of stars in the sky that happens in the wintertime, like now. So this is the brightest star in the constellation Auriga, and it usually in most Western artwork is featured as a baby goat. So I always think that's kind of fun. Auriga itself is a charioteer in Greek mythology and is often associated with Bellerophon as well. So you can see the star right here. It's got those stereotypical, what we call diffraction spikes, the thing that makes it kind of look like a cross. And that is a result of the light kind of bending around the secondary mirror of our telescope. This is an issue that you get with reflecting telescopes, because they have secondary mirrors that the light has to pass around before it gets to the eyepiece. So, or the camera, right? So Capella, absolutely gorgeous star. I always know winter is right around the corner when I start seeing Capella rising over the eastern horizon. Love this star. So we have Jasmine Mangyari. I am sorry if I have botched your name a little bit, has requested the Whirlpool Galaxy. However, that one is still a little bit too low for us right now. That's located in the constellation Ursa Major, and that's still rising on the eastern horizon. So we're not going to be able to take a picture of the Whirlpool Galaxy tonight. However, if you come back probably at the end of February, it will be high enough for us to get. We also have the issue of that one being really far north for us, and in the north of our telescope is a large building, as the building that the telescope is housed in. So sometimes we can't see things that are too far north. And then, but we do have requests for something called Lunar X and V. Oh, Lunar X and V. And my sources have told me that we can't actually look at those tonight. I'm not too sure what those are, but it looks like it has something to do with the moon. So we might have to wait for the moon to be up for those ones. But Bob F has requested, he wants to see Epsilon Lyrae or the double-double, and I'm fairly certain that we can actually split that in. So let's go ahead and get Epsilon Lyrae up in our camera, also known as the double-double. So we're just going to wait for the operator to go ahead and get that in the telescope there. But we can talk a little bit about Epsilon Lyrae. This star is called the double-double because it is a binary star, but it's not just one binary star. It's actually two binaries. And so when we look at it through a telescope through the eyepiece, you would actually see, two stars, but each of those stars is its own binary. So there's 4 stars there. It is actually quite pretty to look at, and our 32-inch star structure telescope can resolve all 4 of the stars pretty easily, and it's quite nice to look at. Epsilon Lyrae is getting pretty low in the sky. I mean, it's in the constellation Lyra, so it is starting to get to a point where we won't be able to look at it anymore. But you can see as they adjust the exposure, they're underexposing it a little bit, you can see 2 separate stars there. And so, yeah, we can actually resolve it. And just know that those 2 stars, each of those is its own binary star. That's double, right? Astronomers really like to be obvious with how they name things. We don't make things confusing at all, which is helpful for me, for sure. So yeah, that's the Epsilon Lyrae. Someone has requested to look at the moon, and I did just mention that the moon is not up. It is actually currently very close to a new moon phase. I think the new moon is tomorrow. Correct me if I'm wrong on that. So it is basically right next to the sun. So we don't want to look at the moon or the sun right now. Also, you'd have to look through the planet. Marie Jardel has requested NGC 891. This is a galaxy. It's actually one of my favorite galaxies to look at. So we're going to go ahead and get that up there. I forget where the galaxy is. I think it's in Pisces. Now this one's a cute little, it looks like a cute little tiny baby when we get the picture all up in there. And we're going to see that it's an edge-on galaxy. So we'll be able to see a dust lane, or this little black stripe right through the center. And we'll see a little bit of a glowing halo of all the stars in this galaxy. Now, presumably, this galaxy is a spiral galaxy. However, because of the orientation of it relative to us, we can't see the spiral arms. It is edge on. And you can actually see if the operator can just hover over the little dust lane there with the cursor. Yeah, you can see the little dust lane there. This one, I think, is a great placeholder for before when the Sombrero Galaxy comes up. We can't look at Sombrero Galaxy until springtime. And I think this is a great substitute for it. It's my second favorite edge-on galaxy. That looks so much better. It's amazing to look at. And you can see there's these yellow stripes, those are the stars, and there's like a little bit of a halo of stars. At the very center where it's the brightest, you're going to have the highest population of stars there. They're going to be densely packed. They're going to be orbiting a supermassive black hole somewhere. Presumably, we have not photographed a black hole in this galaxy yet. And then, of course, we have this dust lane where it's very populated with planets and other stars and a lot of dust and a lot of gas. And this galaxy is fairly young. It hasn't interacted with a lot of galaxies yet. So it's got some structure to it. And we're going to be seeing a lot of star formation coming out of this galaxy in the next coming several billion years. So absolutely one of my favorite galaxies right here. And then, we're going to go ahead and look at, sorry, I'm just trying to look through all the requests here. All right, so we're going to look at the Crab Nebula. We have a request from Avery Squires, which is M1. And Crab Nebula is, it's one of my favorite things to look at through a telescope when I'm at work. And it is it is the brightest supernova remnant that we can see in the Northern Hemisphere. And this Crab Nebula, it's pretty interesting because this was a supernova that happened a little bit less than 1,000 years ago. Now, a supernova happens when a massive star, like Betelgeuse, explodes. It loses its energy. It can't fuse heavy elements anymore. So its core collapses and it causes this whole chain reaction, which results in a very bright, very energetic explosion, which we call a supernova. And supernovae, when they happen, are so bright that they're usually brighter than the galaxy itself. When it happens close enough to us on Earth, we could actually see it with the naked eye, like this Crab Nebula right here. This happened in the year 1054 AD. It was visible with the naked eye. Telescopes weren't invented yet. And so when people saw this, it looked like a bright star that appeared. And it was bright enough that people noticed it enough to write it down. And this is, in fact, the first documented supernova that we have on record. And there are documents from all around the world, especially over in China, Korea, and Japan. There's so much documentation about the history of this. So this is one of the supernovae that we know the most about. Now, we can't see it with this camera because our camera is a visible light camera and it's attached to a 14-inch telescope on Earth. But if we could look at it in X-ray, you would be able to see a neutron star at the center, and the neutron star would be emitting jets of light out of its poles as it rapidly spins several hundred times a second. We would call that a pulsar. And it does have one of those in there. And so that would be the result of the collapsed core of the massive star that exploded. Now, of course, some stars are massive enough that instead of a neutron star, you get a black hole as a result. But this is not one of those. So Crab Nebula is always stunning. It's one of the stars of the pun not intended, stars of the show during the winter sky. And during the summertime, we don't really have any supernovae to look at. So I look forward to the winter if I want to talk about supernovas. All right, next up, we do have 2 requests from Joe Wolfs. So Joe has requested M42, which is more commonly known as the Orion Nebula. So we'll go ahead and we'll just get M42 right in there. And you thought the star cluster that I was looking at was interesting. This one, you're going to see that nebulosity much better. And we will probably just need really low exposure time for this. M42 shows up really easily. You can actually see it with the naked eye. It looks like a single star in the sword of Orion, which is just south of the belt, right? And it looks like a single star, but when you zoom in with a telescope, you're going to see it's actually kind of like this great big cloud, like this one. And it is overexposed at the center, but that allows us to see the nebulosity around it. You can see the dark nebula in the front. And then, so what the telescope operator did was he changed it over to video mode on our camera so we can pick out some of these stars at the very center. You can see 4 stars that are clustered together, and that cluster is called trapezium. And these are brand new, freshly born stars. And they are currently, among hundreds of others, accreting mass from the gas around them, forming these new stars. So as I mentioned before, the way that stars are formed is the collapse of a massive cloud of gas. It's a little bit at a time. It starts to, as it gets more gravity, it starts to pull in more and more material until eventually it gets massive enough and it starts to become hot enough that it shines. And these are what we would call protostars. And so that's what we have. These stars at the very center, these are about 40 times more massive than the sun, which is an insane number. In order to go supernova, a star would have to be just barely 2.4 times more massive than the sun. We have this long exposure picture back up again so we can see the cloud around them. You can see there's a dark cloud in the front and with a little bit of reflection of the starlight behind it, which makes it really, gives it that 3D look to it. And then we can see some of this pink and blue emission nebula around it. And again, this is glowing because of the energy from the stars inside it. So Orion Nebula is absolutely, this one actually steals the show. Like, scoot over Crab Nebula. Let's look at the Orion Nebula. We also have a request for M31 from the same person who requested M42. Joe Wolf. So we're going to go ahead and look at M31. And this is the Andromeda Galaxy, which is the brightest galaxy in the Northern Hemisphere. This is the most distant light that we can see with the naked eye, as the Andromeda Galaxy is about 2.2 million light years away from us. And but this galaxy is about twice as big as the Milky Way. It contains about 1 trillion stars. and its size is about the width of 6 full moons, or 3 degrees. So we can see this with the naked eye, technically. It looks like a very, very faint star. So when we get in real close, it's really easy to get in close with this. You can look at this with a pair of binoculars and you can see the whole galaxy that way. Because the way that our camera works, we're zooming in much too close to see the entire galaxy. So we're actually seeing the very center, we're seeing the core or the galactic bulge. And that's the bright area that's just a collection of probably billions of stars, redder stars mostly, as they've sort of migrated that way. And then around that, you can see the spiral arms. You can see a little bit of dust and a spiral pattern around it. There's these dust lanes. So this galaxy is not entirely edge on, and it's not entirely face on. So we can see that it's a little bit of in between. But we can still tell that it is a spiral galaxy. The neat thing about the Andromeda Galaxy is that Andromeda and the Milky Way galaxy, the galaxy we live in, are on a direct collision course with each other and will collide and eventually merge in about 4 to 7 billion years. So mark your calendars. You thought 2021 was going to be an interesting year. So they will start to collide and they will merge. The supermassive black holes at the center of each galaxy will merge together and they will form one new galaxy. And astronomers have called it Milkometa because, as I said, astronomers are not creative with their naming at all. All right, so we do have someone who has requested the Perseus double cluster. Chris Georgi has requested this. And we can see it, but we can't see all of the cluster at once. As we saw here with the Andromeda Galaxy, you can only see part of it because our view is so close in, it's a very small field of view. So we can see 1/2 of the double cluster at a time. So we might as well go over to that. We'll look at NGC 869, which is, I can't tell you if it's the left half or the right half. So it is one of the halves of the Perseus double cluster. And again, the double cluster is it's a really big object in the sky. It looks really good with binoculars, or if you have a wide field view telescope, like our 5-inch Tech refractor that we have at our Open Deck Observatory, we can see both of them very easily together. And to me, it kind of reminds me of mitosis, I think is the word, when 2 cells are splitting. That's what I think of when I look at the double cluster. That just shows that I'm a nerd in many ways and not just in space ways. So this here is NGC 869. This is 1/2 of the Perseus double cluster. And if we could go over to NGC 884, so we could see the other half of the double cluster, we might as well get the whole experience, just a little bit at a time though. And so these stars, this is another open cluster of stars. They're all relatively young. They all formed in the same kind of cloud of gas like we saw with trapezium in the Orion Nebula and with NGC 1893, which I had at the very beginning, right? But the difference between these ones is these ones have used up all of the gas and now there's none left. And these stars are eventually going to migrate away from each other over millions or billions years of time. They're going to eventually be so far apart that they're not even going to know they're related. And so that is both NGC 869 and 884 are part of the same cluster, and it's sort of segmented into 2 bits there. All right. And then, we have someone who wants to see the star Rigel. So we'll go ahead and go to Rigel. Daniel Milletz has requested that. Absolutely gorgeous star. This is the brightest star in the constellation Orion. And I believe that Rigel is Arabic for foot because it is Orion's foot. So we'll go ahead and get Rigel on there. It's a bright blue star. even with the naked eye, you can tell it's got a bluish hue to it if you really pay attention, right? This one is Rigel's left foot. It's just south of Betelgeuse, which is the other famous star in Orion. So there it is, right? This one, again, another star that's part of the winter hexagon. So we looked at Capella, and now we're looking at Rigel. So we did have Chris Georgi asked if this camera is a SCT configuration, and my sources have told me that yes, it is an SCT configuration. So I hope that helps you answer your question there. Jonathan Walker has requested Uranus, and he also said it's near Mars these days, right? And that is absolutely correct. I believe that in just a couple of days, Uranus and Mars are going to be in conjunction with each other. So if everybody was paying attention to the Jupiter-Saturn conjunction, they appeared very close to each other in the sky. We could see Jupiter and Saturn in a telescope at the same time. And a conjunction happens when two planets, or objects really, happen to move in relatively close in the sky. And so Mars is a naked eye object. You don't need even binoculars to be able to see Mars. You can point out pretty easily, it looks like a red star, but Uranus is very faint to see, and most of the time is incredibly difficult to see with the naked eye. Although I've been told it's basically right at the threshold of what you can and can't see. So for people who are stargazers like myself, who like to use binoculars or manually operated telescopes, you might want to try and find Mars. And then Uranus is just going to be a couple fingers widths up from Mars, a little bit farther north than Mars. And I believe they're about 4 full moon widths apart. That's going to be how close they're going to be together during this conjunction that's happening. So as it turns out, Uranus-Mars conjunctions happen pretty frequently. I can't tell you how frequently, but much more frequently than a Jupiter-Saturn conjunction. And these are prime opportunities to be able to see Uranus. Now in the photograph here, you can actually pick out some of Uranus's moons. I can see 3 of them, what I think are 3 of its moons. And the 2 brightest are Miranda and Ariel. And I forgot to check myself last time, but I think Oberon is that little tiny bit that's kind of just touching Uranus a little bit. It's very faint looking, and that would be the 3rd brightest one. All of Uranus's moons are named after Shakespearean characters. So if you really like to read Shakespeare's plays and you're a nerd about that, Uranus might be your favorite planet. And then, so someone did request the Andromeda Galaxy. So we did already look at the Andromeda Galaxy. That was the same thing as M31. So if you want to go look at that, you can always go back in the video and look at that there. And it will be visible for probably maybe a couple of months. I anticipate we'll be able to see it into February, but it's starting to get closer and closer to the western horizon, and it will eventually disappear from view for the summertime. So get your looks of it while it lasts. All right, so I'm gonna go ahead and, so apparently I misinformed everyone, and I apologize. We were looking at a double star earlier, which I claimed was Epsilon Lyrae, and it turns out Epsilon Lyrae has in fact set, and we had been in fact looking at Mesarthim, which is another really pretty double star, and where you can discern the 2 separate stars, but I'm not too sure whether or not those are multiple stars or if it's just the 2. All right, so we have another request from Spike J. It looks like we're running out of time here, so I'm going to go ahead and we'll do this one request from Spike J, NGC 1360. And then we'll go ahead and we will go to the Sculptor Galaxy, and we'll end with the Sculptor Galaxy today. So I didn't realize that we had gotten already up to 8:30. my telescope operators are very cold. It's very chilly here in Flagstaff, Arizona, and so we don't want to keep them too long. So we're going to go ahead and look at this. I forgot what we were saying we were looking at. Oh, NGC 1360, which is another planetary nebula. You can see this little blue boy right in the middle there, right? So planetary nebulae are absolutely A1. They're some of my favorite things in the sky, and there's an abundance of them in the sky. So as I mentioned, those are the results of small sun-like stars that have long since lost all of their energy, and they're essentially what we would call dead stars. And so you can see it's a little blue dot in the middle. So let's go ahead and we'll look at the Sculptor Galaxy, and that's going to be the last thing that we look at for tonight, just because we are getting well, I'm not cold. I'm in my heated home, but my co-workers are very cold out in the out at the telescope deck. So let's go ahead and look at this on one last galaxy. And so Tom Sarko has requested this. I like the Sculptor Galaxy. I always hope someone's going to request it because I never seem to do it myself. And then while we get this up here, I just want to remind everyone that's watching, I want to thank everyone, first of all, for joining us for our interactive stargazing tonight. If you want to give us a like, that would be great. And then subscribe to Lowell Observatory's channel. Lowell Observatory is a nonprofit, a privately owned research institute. We do a lot of great scientific research out here. Astronomy research, we study literally everything. You name it, we probably study it somewhere. And all of our funding comes from the general public. It comes from our members, and it comes from people that are viewing our YouTube channel. So we absolutely appreciate everything that you guys do for us to keep on looking at amazing things and doing great research. And of course, if you subscribe, you can check out, hit that notification button, and you can also tune into some of our other live streams that we have. I know that we cover pretty much anything interesting in space. We'll cover it, full moons, conjunctions, eclipses. We'll probably have it covered in a live stream, as well as our cosmic coffees that we release every week on Thursdays, I believe. Yeah, so this is our last object right here. This is the Sculptor Galaxy, NGC 253. This one's really low in the sky pretty much all the time for us. So this is always going to have like a little reddish tint to it. But you can see kind of like the Andromeda Galaxy, it's a spiral galaxy that's not quite edge on and not quite face on. And you can see a lot of like dust. And this one's actually much dustier than the Andromeda Galaxy. A lot more of those stars are being obscured by the junk that's in front of them and around them. So that's the end of the live stream. I want to thank everyone for coming in again, and have a great night.